Is everything looking good on
Every
YouTube?
Yeah, it's we are live now.
Okay, great. Let's go.
Yeah. Hey everyone, this is Harpal from the Celo DevRel team. Good morning, good afternoon, good evening, wherever you are joining from. Today we are doing the workshop for the BW Series Hackathon, which is between Celo and SuperFluid. Today with us we have Sunny from SuperFluid. Sunny, would you like to introduce yourself to the audience?
Yeah, absolutely. Hey guys, I'm Sunny from SuperFluid Developer Relations. Really pumped to be here today. Show you guys how to build some really cool applications on top of SuperFluid with Solidity on Celo. And yeah, just happy to be here and get to teach with you guys.
Awesome. So let's first learn about Celo. Meanwhile, feel free to ask questions in the YouTube chat or Twitter. So what is Celo? Celo is a layer one blockchain, and we are working with a purpose. We want to create conditions that lead to prosperity for all. We want to include everybody in this digital economy, and we want every average human, which is non-technical, to also take advantage of the blockchain ecosystem. So if you go to the next slide. Here are some of the Celo features. So we are proof of stake L1 blockchain, EVM based, which means all your Solidity smart contracts will work out of the box. We are optimized for mobile. We have very fast transaction finality. You can pay a transaction fee using the stable coins. We have three of them supported as of now. And we have a lot of refi projects, which are refi building blocks in order to help you achieve your refi needs. The entire process of governance, the upgrading of the seller blockchain, and the proposal mechanism is on chain and visible to everyone. We also have support for cross chain bridges. We have a lot of stablecoin support. We are carbon negative from day one, and we have support for ultralight clients and very low transaction fees, and support for leading Web3 primitives and toolings like Superfluid. So, Celo by the numbers, we have crossed 260 million transactions as of today, and we are targeting everybody who holds a smartphone. We have over 29 million unique wallets. We are having 1,000 plus projects building on Celo, including Superfluid, and we have given out 60 million in grants this year. On top of that, since we are carbon negative from day one, we have offsetted over 4,000 tons of carbon dioxide. And a quick note about Celo Composer, you can use this command to basically create a Celo Composer template. If you, Sunny, if you click twice again.
Okay.
Y- Yeah. So we can so this is a Celo Composer template, which I highly recommend that everybody who is participating in this hackathon use. It will get you started in less than a minute. All you need to do is run this command, select the various select your front end framework of your choice, the contract framework of your choice, and you will be set up with RainbowKit, Wallet Connect V2 support, everything that you would need in order to get started. So you don't have to figure out and go through various documentation and figure out how to get even started. And you can scan this QR code to learn more about Celo Composer and what other things can you achieve with it. We have React template, we have React Native, Expo and without Expo, Angular and Flutter. So yeah, use Celo Composer, highly recommended for your projects. And with that, I would like to pass over to Sunny to talk more about Superfluid.
Awesome. Thank you, Harpal. And yeah, just happy to be breaking down Superfluid for you guys. I understand that I'm speaking to an audience that's mostly Celo folks, so I want to make sure that we get a pretty good conceptual deep dive into what Superfluid is so that we can build on top of these concepts going into the development part of the workshop. So what Superfluid is at the end of the day, it's an EVM smart contract framework. It's a bunch of smart contracts out there on all the big main EVM mainnets as well as test nets that allows you to do one very cool thing amongst other things, that being money streaming. So money streaming refers to the continuous per second movement of tokens between accounts. So the way we traditionally experience moving tokens between accounts is discrete lump sums, right? Like I transfer you 10 DAI, that's a discrete lump sum transfer. with money streams, we're able to move little bits of tokens between accounts in a real-time per second basis. You can kind of see the animation illustrating that above. And this is all done with no delays, no payment risk, and no intermediaries, thanks to the finality and instant settlement of just basic blockchain technology. So what's the point of all this? Why are we kind of doing this? So the kind of motto here is, as the internet is to information, blockchain is to value. So what SuperFluid is doing is it's moving value at the speed of the internet, right? The internet allowed us to program information in a way that we never were able to. And that programmability is now afforded to us in the blockchain when it comes to value, right? And so we see all this kind of innovation in DeFi, but a lot of those basic payment primitives have not been improved, right? We're still moving tokens in lump sums, and the overall experience of money has not changed all that much. And so what SuperFluid is bent on doing is improving and extending the way that we move value and pay people on the blockchain. So one good kind of, core sort of anecdote to illustrate and encapsulate that is the analogy of the client-provider payment relationship, right? So if I'm say a Solidity developer and I'm working for I'm working for Bob. Bob needs my Solidity skills, and so when I provide Bob my value by writing smart contracts with every keystroke, with every minute, with every second that I'm logged in and I'm working for him, I'm providing him value in real time. However, at the end of the month, that is only when he pays me, right? So I'm giving him all this value through the course of the month, only to be paid at the end of it, right? And so basically, Bob, at the end of the month, the key word being that he owes me that payment, right? And so that's what I call frictional liability. With real-time payments, we're able to match that output of real-time value provided by the provider to a real-time payment of real value, real money to the provider from the client, right? And so by matching the value in to the value out, we're able to create a better payment experience thanks to the programmability of value offered to us by the blockchain and the SuperFluid protocol. All right, so let's give an overview of what the SuperFluid protocol is. The SuperFluid protocol is an extension of the ERC20 standard. That's really what it boils down to. It takes the ERC20 standard with its basic kind of money movement functionality, such as transfers and approvals, and it extends it to do more things, right? Amongst those more things is money streaming, that being the real-time payment that we were discussing. And basically, this is done with this kind of like three-part framework. So super tokens are what you kind of interact with, what's moved between accounts when it comes to SuperFluid payments. We have the SuperFluid host, which is kind of like the brain of the protocol. It connects everything together. And we have the super agreements, which are pieces of logic that define these additional balance movement functionalities. So we have a super agreement for money streaming. We call it the constant flow agreement. And basically that logic when it comes to the real-time, money streaming, that functionality, that logic is connected to super tokens through the SuperFluid host. So at the end of the day, we want to understand that SuperFluid is modular and extensible, right? So we can make more super agreements with more kind of logic and additional new ways to move balances. So this is a very kind of modular connected protocol in that sense. I want to dive into super tokens a little bit deeper. Like I said, they're ERC20 compatible. So just like how you call balance of on ERC20 tokens, you can call balance of on super tokens. You can do transfers. All that basic stuff is available in super tokens, plus the additional SuperFluid protocol stuff, right? So money streaming, the ability to approve another account to start streams on your behalf. That's all afforded to you through the SuperFluid protocol, and that additional functionalities on super tokens. And because they are, at the end of the day, ERC20 tokens, just extended, they're usable anywhere in Web3. So for instance, you can make a DeFi protocol that allows you to borrow against your super tokens. So yeah, but basically, at the bottom line, they're tokens, right? This is a token-centric protocol. Super tokens come in two varieties. We have wrapper super tokens, such as DAIX or ETHX. These are wrappers around existing ERC20 tokens that allow you to basically wrap an existing ERC20 token into a super token version of itself and stream that. And if you'd like the underlying token again, you can unwrap, right? So the key thing to note here is you can't stream plain DAI. You'd have to wrap it into the super token version of itself, that being DAI X or super DAI. Wrappers are denoted by the token symbol with an X at the end. And these wrappers, they're permissionless. So I can say, make like my own token, call it like Sunny token, and I can make a Sunny X wrapper for it, and I can start streaming it. So it's very kind of a permissionless and open. We also have pure super tokens. Pure super tokens are super tokens where the supply is fully streamable from the get-go. These are tokens where they are born as super tokens and exist only as super tokens. There's no need to wrap and unwrap. They're just super tokens all the way through. So one important concept that I want to hit on, because we'll be doing this for today's workshop, is the idea of super apps. So basically, super apps are smart contracts that can react to streams, right? So some of you may be familiar with the ERC. Man, I'm blanking on it. Harpal, do you know the ERC standard where it's got like hooks on it? You can basically like you can define like an on received hook on a smart contract, and it'll
721.
Right, I know ERC 721 has it. I think there's another standard as well that's like more geared towards ERC 20. But yeah, that's a good example.
777.
Yes, 777. That's what I was looking for. So ERC 777 and ERC 721, they define kind of like on received hooks, such that when you transfer tokens to a certain smart contract, you can define this on tokens received hook that gets triggered when tokens are, sent to that smart contract. Just like that, with super apps, we have these things called callback functions that are these special functions that you can write into a smart contract. And when you start a stream, you start streaming tokens to the smart contract. These special callbacks are triggered accordingly. So you can kind of see that in this flow. Basically, you register your smart contract with a SuperFluid host. And then when a stream is started, the SuperFluid host identifies, okay, this receiver is in fact a super app. It's been registered. And let's engage this appropriate callback logic on the super app in response to you starting the stream to that smart contract, that being the super app. So this callback functionality can have any kind of logic. You can customize it to your pleasing. You can make it do whatever you want. You can make it, mint you an NFT. If you start a stream to the super app, you can make it start another stream to another account. If you start a stream to the super app, it is very customizable, and it affords you a additional layer of programmability. So it's really cool, and we'll be using this today. I want to also hit on the Super Token V1 library. This is the #1 way to integrate SuperFluid into your smart contracts. It's simply a library that you import, and it allows you to basically really easily manage streams in your smart contract. So you can see it's almost akin to ERC20, the experience of building on top of ERC20. You're simply calling token.createFlow, receiver, and then flow rate. It's almost like token.transfer, receiver, and then amount you'd like to transfer. So it's a very kind of familiar developer experience. All right, it's time to build, guys. Let's do this. Just going to take a step really quick. Here we go. I'm going to exit the presentation really quick. Oh, actually, I want to hit on what the project is before we actually get started. So today's project, we're calling it Streaming Donation Existential NFTs. That's kind of a mouthful. But really all it is a smart contract, that being a super app, that reacts to a money stream and mints you an NFT in response. So this money stream that you send to the smart contract, this is like a donation stream. It's like you're donating to a certain cause in real time. And then the donor NFT, this is a NFT credential kind of that shows on chain that you are currently donating to this cause, right? Now, on the other hand, if you cancel your donation stream, the stream in contract burns your donor NFT because you're no longer donating to the cause that you're paying for or donating for. So that is the basic mechanic here. We're going to be using SuperApps. We're going to be doing a good amount of Solidity here. So buckle in and let's get into the code. All right. So I've got my Remix IDE open here. Are you able to see this, Harpal? Harpal, can you see this?
Would you like to zoom in a bit in the code side?
Okay. Yeah, absolutely. Does that
Yep,
look better?
that's good.
Excellent. Yeah, so quickly want to touch on the imports. SuperApp base flow, this is kind of like a base contract, a base abstract contract that you want to import. It exposes those basic callback functions like I talked about, the functions that are going to be triggered when you start streams to the SuperApp. So you want to make sure that you import this. It's going to be like your SuperApp template, so to speak. We're importing these interfaces from SuperFluid for the super token and then the SuperFluid host. You'll see that in a moment. We import our super token v1 library to make the process of interacting with the SuperFluid protocol better in Solidity. And then we also import ERC 721 because this is really an NFT contract that we're working with here. So first off, we're making sure the contract is the SuperApp base flow and it's an NFT contract. And then we are using the library for super tokens, right? So this is how we initialize the library, and we make sure that when we work with super tokens, we're able to, get a hold of those basic functions like create flow, update flow, and basically improve the ergonomics of interacting with SuperFluid. We are storing the accepted token. So right here, we don't want to be, working with every single token. We don't want to be accepting donations in every single kind of super token, right? So with accepted super token, accepted token, we're defining the donation super token that we want. And then we're setting an inflow threshold. So basically, in order to receive a donation NFT, you have to stream at a rate greater than this inflow threshold. If you stream too little, then you're not going to receive the NFT. But if you stream enough, then you'll be minted the NFT. This is the token ID counter. Just keep track of what token ID we're on when we're minting NFTs to people. And then we're mapping up the NFT owned to different addresses. And the reason we have this mapping is because the NFT owned to the owners, that is a one-to-one relationship, right? You can't have multiple donation NFTs because it's existential. As long as you're streaming, you're going to have an NFT. And if you stop your stream, you lose your NFT, right? You can't have multiple streams going to the same smart contract. It's always just one stream. And as a result, you're always going to have one NFT. So to help us track for each address, the NFT that they own, we're making this mapping. The ERC 721 only affords us the ability to see for each NFT token ID, what is the owner, right? This allows us to see what NFT the owner possesses, right? Because we know that the owner is only going to have one NFT. So that is the deal there. I hope that made sense. You'll see why we did this when it comes to the callbacks in a second. But let's get into the constructor. So we define the accepted token, we define the inflow threshold, and then we take in the SuperFluid host, and we feed that into the SuperApp base flow. And you'll see that we have a bunch of these booleans here. Basically, all these are saying is, I'll go to the SuperApp base flow just so you guys can see under the hood. We're defining whether we want the SuperApp to engage that callback logic to react when a stream is either created, updated, or deleted. And because this streaming contract is going to react in all three cases, if you create a stream to the contract, it's going to react with something. If you update your stream, it's going to also react. And if you delete your stream, it's also going to do something else. We want to make sure that these are all in activation. And we will say true, true, true. However, let's say we don't want the contract to react to a stream that's being sent to it being updated. We would set this to false. But like I said, that's not the case today. We want all our callbacks to be ready to go. So, yep, and then we just kind of set our ERC 721 there, and then we set our state, and we're good to go with the constructor. So that's the constructor. And also, Harpal, if you're noticing any questions in the chat, feel free to interrupt me. But let's keep on going. So yeah, the super app base, it also exposes this is accepted super token function. This function is where you define, hey, I don't want this super app to be reacting to any other super token than the accepted token. We can set different logic in this. It's customizable. Let's say we want to have 2 different accepted tokens, or we want to accept every token for some reason. Then this is accepted super token function can be overridden, and we can, customize the logic to our pleasing. But today, for this stream and super app, we want to make sure that we're only accepting the accepted token that we set, right? So we basically override this is accepted super token function that's provided in super app base flow. You can see it being exposed here, and we set that logic into it to make sure that our callbacks are only being activated when it comes to the accept token and no other token. So yeah, that is that. And also we set our token URI here just before we get to the callbacks. This just makes it such that our NFT metadata is always the same. So you're always seeing the same image regardless of what NFT you're minted. So that you can see we're always returning the same string here, which points to some imagery, which you'll see when we get to the deployment part of this demo. All right, so let's get into the fun stuff, the callbacks. So like I said, the callbacks are the functions that are triggered in response to different stream modification actions. So the first callback we have is called onFlowCreated. It's exposed in our super app base flow, right there. We're overriding it, and we're writing in our custom logic. So this is our custom logic. You'll see onFlowCreated, just to review the parameters. We get super token of the flow being sent to the streaming contract. We get the sender of the stream being sent to the streaming contract. And we also get this context. You can think of the context as kind of like the initial state of SuperFluid before the onFlow, before the kind of callback is triggered. Now, this context variable, it needs to be modified if you do more SuperFluid things in your callback. So let's say in here we start a stream in this callback. Then we would need to do some special function and basically modify this context variable to reflect the additional SuperFluid stuff that we did. However, we're not doing any SuperFluid stuff. We're not starting any flows. We're not doing any kind of SuperFluid write operations. So as a result, this context variable remains untouched, and we actually just straight up return it at the end of the callback. I can actually just delete that, but we're just returning context at the end, totally unchanged. And this context, it just goes back to the SuperFluid protocol and indicates, hey, we didn't do any SuperFluid write operations in this callback body. Nothing really changed. Nothing that concerns you. So that's what this is about, just in case that clears things up, in case you were wondering. But yeah, basically what needs to happen here is we're seeing in this onFlowCreated, this is like the core logic here. We're getting the flow rate. We're seeing if it's, then we're seeing if this inflow rate is greater than the inflow threshold, which we set up there. And then if it is, then we mint the sender a token ID. We mint the sender an NFT, right? We also set that NFT in the NFT owned mapping. That's what happens there. Pretty explanatory. onFlow updated is where things get a little bit more complicated. So this is what happens. So this callback is triggered if you're already streaming to the super app, that being the stream-in contract, and you change the rate at which you're streaming. You update your flow, right? If you do that, then this function is triggered, and this logic is fired is triggered. So as you can see, we get the super token, we get the sender, we also get the previous flow rate, right? So we can see what the previous flow rate was before you updated it to the latest flow rate, right? So that is going to be valuable to us. Basically, we get the current flow rate with this line. We see if the current flow rate is greater than the inflow threshold, and we see if the previous flow rate was lower than the inflow threshold. So basically, what this is telling us is if you are moving from, having been streamed, we're seeing if you are moving from having been streaming too little to the contract to enough to the contract, that being over the threshold. And if you are, then we mint you an NFT. On the flip side, if you go from streaming over the threshold, you're above the threshold or at the threshold, and you go to streaming less than the threshold, then we, on the other hand, burn your NFT because you're now streaming too little. So that's all that's happening there. And yeah, that is what happens when you update your stream to the stream mint contract. And yeah, lastly, if you delete your flow to the stream mint contract, then your NFT is burned, right? So that's what's happening there. And yeah, obviously we want to check if your previous flow rate is greater than the inflow threshold. If you were already streaming too little and you just cancel your stream, then you already won't have an NFT in the first place. So we wouldn't want to burn an NFT that doesn't exist. That would just error out. So that's what's going on here with this piece of logic. So that is the entire contract. It was pretty short, just 143 lines, and it gets the job done. I want to reiterate that these callbacks, they're triggered in the same exact transaction as your stream operation. So let's say I start a stream to this streaming contract, I create a flow. This function literally runs in that same transaction, right? And this is it all happens all at once. So you can see how powerful that is when it comes to adding little bits and pieces to the experience of streaming money. So that is that. I now want to move on to the demonstration part of this and actually deploy this code. Remix makes our life super easy here. So let's go ahead and do that. So I'm going to switch my MetaMask to the Celo mainnet. Right here, from Mumbai to Celo. I'm going to take a moment and say that this workshop is in honor of the SuperFluid Wave Pool Hackathon, as well as Celo's BWC Hackathon. And in order to be eligible for prizes, you have to be able to deploy your application on Celo mainnet or have it use Celo mainnet in some way, shape, or form. And so, yeah, that's kind of the point of this demo. The reason that I'm going straight to mainnet to show you guys just the process, just kind of a walk the talk, so to speak. So here we are on Celo. I've got some Celo tokens. Let's get to deploying. So I'm going to compile this. All right, just a little warning around that token URI function, but it's all good. Let's connect to Celo. All right, we're good to go. All right, now we want to input the right addresses for our constructor. So I'm going to go to contract addresses in our documentation here. You can find this in docs.superfluid.finance. I'm down in the contract addresses section, and I'm on the Celo tab right here. I get the SuperFluid host right there. I'll paste that in. Let's just make the inflow threshold 100. So when we're talking about rates, right? When we're talking about flow rates when it comes to SuperFluid, these are always in Wei per second. So when I'm streaming at a rate of 100, that's really saying that I'm streaming 100 Wei per second, okay? So that could come down to whatever kind of monthly rate that is, but these numbers are always Wei per second. Let's say for the accepted token, we want to accept Celo USDC. I've got some Celo USDC on me, so I should be fine to go for this. And let's deploy. Popping up on my MetaMask to confirm it. All right. So now we've got our stream mint contract right here. And all that matters is that we were able to start streams to the stream mint contract. All right. So cool. That is the contract. We've deployed it. It's out there on the Celo blockchain. Now I also want to go through and demonstrate the SuperFluid Checkout Builder. So instead of making a front end and going through the struggle there, let's just use this checkout builder to create a SuperFluid subscription widget that will allow us to easily start streams to that stream mint contract. So I'm going to copy the address of the stream mint contract. And I'm going to paste it in as the receiver wallet address. So now I'm going to take a quick step back. Basically, all we're doing here is we're constructing this this widget here, this kind of checkout experience, using this no-code tool provided to us right here in the checkout builder.superfluid.finance. And yeah, that's all there really is to it. It's quite simple. So I'm from Philadelphia. Let's say I want to donate to a local charity called Fill Abundance. I'm going to make the product name that. I'm going to give a description, call it Fill Abundance donation, platform, site, Fill Abundance. And then we're going to define a network, Celo. We're going to set our super token as USDX. We're going to set our stream rate to something really low, like a cent per month, just for the sake of this demo. So I have enough USD on me to accomplish this. And we're going to delete the default that we have here, and we're going to add in what we just customized. So boom, right there, we see the default payment option, and we can actually get to work with it. Let's customize the UI a little bit. So let's add in a product image. So what do we have here? Fill Abundance. Yes, you guys can tell I came prepared. Primary color, let's make Fill Abundance a bit of a darker green. Yep, we like that. Let's make secondary color black. And then we can customize the font if we want. Kind of like that. Let's go. Cool. That's a good one. Right, and we can make the stepper horizontal or vertical. So a couple more options there. But yeah, that's the deal there. Let's set it to dark mode because we like dark mode, and let's get straight to exporting it. So the widget, the widget customizer allows us to quickly publish this to IPFS. So now we have this shareable link to work with our widget on. This is out there. I could send this to you guys, and you guys will be able to try starting streams and using this widget if you have the tokens. I'll quickly stop over the comments and drop it there so you guys have it. That is that. And yeah, let's get into it. So let's start our first stream. Let's connect my wallet. All right, my wallet is connected. And it looks like I don't have the CUSDCX. Let me just double check on the SuperFluid dashboard that I have the appropriate balance of CUSDX to do this demo. So I'm going to switch to Celo. Purchase page. Oh yeah, so I do have enough. Cool. I guess it's just rounding down to 0. I'm going to skip this step, because I already have enough super tokens. And I can start the streams right here. Now, what I want you guys to know, what you're about to see here is I'm going to start the stream to the stream and contract, right? And what's going to happen is we're going to trigger this on-flow created function, this callback, and this logic is immediately going to be triggered. And because we're streaming above this 100 wave per second rate, we're immediately going to be minted an NFT. So I'm going to do that, and I'm going to show you guys a transaction, and we're going to see that NFT being minted. So let's do this. So I'm going to send a stream. Here we go. Confirm. I'm going to pull up this NFT viewer. I have written down somewhere. All right, so we are successfully streaming to the streaming contract. Let's review the transaction. Create flow. Great. All right, so look at this. So we see the stream mint NFT has been minted to us. We see that the constant outflow NFT and the constant inflow NFT, these are kind of like on-chain markers for the SuperFluid protocol to kind of identify that we're streaming. Don't worry about these guys. What matters is that we have been minted a stream mint NFT. Now let's go view that NFT on this NFT platform that I found. And sure enough, you can see that we have a Fill Abundance NFT. Boom. And yeah, it has just been minted to us. We can't really see like when it's been minted, but you can see here that it came through this transaction 28 seconds ago. So yeah, that's the deal here. As you can see, it happened in the same exact transaction. I didn't have to like go somewhere and claim the NFT. I just started the stream and boom, I was minted the NFT because it was coded into that callback logic. Now for the last part, I just want to cancel my stream and show you guys what happens. So I'm on the dashboard. I'm going to go here. I'm going to go to my stream. I'm going to cancel it. All right. We're in the process of canceling. Here you should see the NFT being burned. So if that goes through, I'll click into the transaction and we'll see what happened. Be a few more seconds. All right. So in the block explorer, you can see that the stream was canceled. We can see that the stream and NFT has been burned. And if I refresh this page, where'd it go? It's gone. You can see that the stream mint NFT has been deleted. So that is it. That is a simple kind of super app that you can build using SuperFluid. And I hope that illustrated the programmability and the power of SuperFluid as a whole with its super app functionality. So yeah, that kind of concludes the technical part of this workshop. Hope you guys learned a thing or two and it inspired you with something to build for this current wave pool hackathon. So I'll return to the slides and kind of close things off. To reiterate, this workshop was in honor of the SuperFluid Wave Pool Hackathon. This is a hackathon that happens every single month with its own set of prizes. This month, we're doing this in collaboration with Celo BWC, and you can, apply your work to this hackathon, and as long as it pertains to Celo and it works with the Celo mainnet, you'll be eligible for around $10,000 worth of prizes. So definitely get in, get hacking, and it's a great opportunity for anyone looking to bolster their Web3 portfolio and potentially earn in the process. Again, here are the prizes. We've got $10,000 worth of them here for first, second, and third, as well as the pool prize. So if you don't quite make this first, second, third cut, but we think you have a good project, then we'll split this pool prize amongst good projects, and you'll be able to earn part of that. We also have a designated prize for the best use of SuperFluid subscriptions. So you saw that widget that I demoed. If you use that in a really nice fashion, then you'll be able to claim this prize here. And that widget can be integrated into any front end of your choosing, and we have documentation on it. So it doesn't just have to be that standalone kind of web page that you saw. You can mesh it into an application and make it look really nice and part of your user experience. And we also have a prize for the best use of SuperFluid and Good Dollar on Celo mainnet. Good Dollar is this kind of like universal basic income project out there, or it's more of like it's a whole kind of protocol. And if you manage to use Good Dollars with SuperFluid for your project on Celo mainnet, you'll be eligible for this $1,500 prize. So that's it. Want to encourage you guys to get in touch. You can find me on Twitter at SunnyJacer. You can find Harpal at HarpalJadeja 11. I'm sure I butchered that, but we're out there. We'd love to help and get you guys some support when it comes to your projects or whatever you decide to put together. So yeah, thank you guys for playing this. Thank you guys for coming out. Thank you guys for coming out and learning. And thank you, Harpal and Celo, for helping put on this workshop. This was a great time today.
Yeah, sure. First of all, thank you for taking out your time to do the workshop. You pretty much built an entire project, right? In this workshop, we basically built the entire hackathon project using the SuperFluid SuperApp, the checkout widget. We basically demonstrated, Sunny basically demonstrated you all the aspects of the SuperFluid protocol and how you can go about building a project. So we expect some really unique cases really unique projects and use cases to come out of this hackathon. And feel free to join the SuperFluid Discord and ask questions. Feel free to join the Celo Discord and ask questions. We have a dedicated channel just for this. And we also have office hours on every Tuesday. So make sure you have signed up for them. With that, let's wait for 2 minutes for questions. We don't have any as of now, but let's see if anybody has any questions.
All right. I'm not sure anymore, right? I stopped that.
Yep.
Okay, cool.
So there's no whitelisting process for the Celo mainnet, right? For super apps. Am I correct?
That's correct. So usually on different mainnets, we have like this whole whitelisting process where you have to make sure your super app you get like a deployment key and you deploy it with the factory. With the Celo mainnet, that is totally off the table. You can deploy super apps permissionlessly, and it's smooth. It's much easier.
Great. Awesome. So we don't have any questions as of now, but feel free to ask questions, guys. Feel free to join the Discord, SuperFluid Discord, and the Celo Discord, and also make sure to sign up for the office hours. And yeah, best of luck and create something cool with SuperFluid on Celo. And thanks again, Sunny, for taking out your time and doing the workshop.
Yeah, I appreciate it. Thank you guys for offering the platform, and yeah, happy hacking everyone who came.
Great. See you guys next time.
Adios.